Hi, my name is Escher Barrett, and this is Physics 2211 Lab 5. The purpose of my lab was to analyze collisions between moving and stationary objects in The Legend of Zelda Breath of the Wild, calculate how much force Link swings the Master Sword with, and determine whether fundamental constants are different to real life. The fundamental principles that I used in this lab, the conservation of momentum, the energy principle, and Newton's second law. The results, or a brief glimpse of the results, is that I found that 95 kilojoules of heat was lost during the collision, and that Link swings the Master Sword with a force of 210.5 newtons per swing, and that the acceleration due to gravity of whatever planet Hyrule is located on is negative 17.78 meters per second. So the experiment consisted of me dropping a box. This is how I figured out the gravitational constant. And then also the collision here on the right. So for the collisions, these were my initial conditions. I figured out the mass of the steel cube by comparing it to a known mass of steel. I used the tracker app to figure out the velocities and the positions of the boxes, as you can see in the graphs on the bottom. And I used the velocity of box 1 and box 2 before and after the collisions to figure out the heat lost during the collision. This is my calculations for that. I used the energy principle. The change of the system is equal to the work plus the change in heat, and came out to find that, assuming that neither block changed temperature, which I wouldn't have been able to measure anyway, by the energy principle, the two-block system lost 95 kilojoules of energy to the surroundings as heat due to the collision. To create the collisions video, I first put the box 1 into a stasis state, which is an ability Link has that can pause the time of an object. And when he attacks this frozen object, it transfers the work from his blows directly into potential energy that will be immediately converted to kinetic energy upon the release of the ability. So to find how hard Link hit the box, or to find how hard Link swings the Master Sword, we can examine the time from when Link hits the object in stasis to when it's released in two separate ways, which I have done, and neither of them give us a clear answer due to the fact that this magical ability does not allow the passage of time and therefore does not allow displacement as well. So unfortunately, our laws of physics do not count for this video game magic. But what if we could make it count? What if we could make it work? So under the stasis spell, it's given that an object will not move through time, but more specifically, I would argue that the stasis spell converts forces directly into energy, or newtons directly into joules. This means that the stasis potential energy is directly equal to the force applied to it. Therefore, the 421 kilojoules of kinetic energy would have been directly converted, or immediately converted from the potential stasis energy, which means that Link, or I took two swings, and so that 421 divided by 2 is 210.5 newtons that Link swings the Master Sword with on each swing. Finally, for the gravity, I basically held up a block using another ability at rest, and then dropped it to find the acceleration due to gravity. It was 4 meters off the ground. I could use Newton's second law to determine the acceleration due to gravity, and I found that to be negative 17.78 meters per second squared. I used fundamental principles of physics to assess the physics in a video game, or a simulation, I guess, and determine differences it has to reality, especially concerning magic.